Hello and welcome to another video by Dr. John Tran Science. So basically, once in a while there are people who need some help in their entrance examinations for medical school, and they ask me for help, and this is one of those occasions. So right now I have a student here. His name is Han. He's all the way, he's from Hanoi, isn't it? Are you from Hanoi?
Yeah, I'm from Hanoi.
Correct, okay, perfect. I'm all the way from Saigon though, anyway, Ho Chi Minh City. Alright, so Mr. Han, he is 18 years old, I guess, about 17, 18 years old, and he has successfully passed his written examination for the University of Debrecen. That's exactly where I graduated from, University of Debrecen from Hungary. So how was the written exam, Mr. Khan? Was it difficult?
I find this very it is difficult. I managed to understand.
So you managed to do it, right?
Yeah.
It was difficult, okay. So we have here topic for biology, chemistry, and physics. And of course, you can choose either biology, physics, or biology, chemistry. So which one would you choose? Let's assume that we have to answer everything. I mean, let's just assume that, shall we? Now, so which one do you would you like to start with? Biology, chemistry, or physics?
Oh, I only have to do biology and chemistry.
Of course, everyone will choose that. Basically, if you are into medical school, you would hate physics. But anyway, be careful with physics. It could be one of your worst nightmare. Anyway, so let's start with chemistry now. And you are not even allowed to choose your topic this time because the examiner are much more strict this year, as I believe, and they also will ask like very detailed question. Now let's start with general chemistry. Can you describe the structure of atoms?
Atoms consist.
The structure of atoms.
The atoms consist of a central nucleus and surrounded by electron clouds. Electronic clouds, and the nucleus consists of two type of particles.
Two type of particles.
Which are the protons and the
neutrons. Proton and neutrons.
Proton and neutrons. The surrounded are called the electrons.
So surrounding the nucleus are electrons. Because surrounded is like passive, you know. Surrounding, it's like active form of verb. Một cái động từ chủ động, cái động từ bị động. You use it correctly. So surrounding the nucleus are electrons. Or you can say the nucleus is surrounded by electrons. So use the passive and active form correctly, okay? Now, so my next question for you is, alright, so can you explain, okay, so what is special about electrons and protons?
The electrons and protons always have the same numbers inside of the atoms.
No, that is not correct. That is not true. Not always.
No.
Because you have ions. Because you have iron. You see.
Yeah.
So it's not always the same. So
always.
you have to say that in a neutral atom. In a neutral atom.
In a neutrals.
In a neutral atom, the number of electrons should be equal to the number of protons. Correct. Be careful because every little details like that matter. So they have to be very strict. You have to be very strict with your wordings. Try to speak slower, okay? Calmer, slower, and mind every word you are trying to say. Because why? It leaves a better impression on the examiner. And also, they take you more seriously. Now, anything else?
Each proton contains +1 charge, while electrons contain -1 charge. And the neutrons are uncharged.
Right. So what happens when the number of protons and electrons are not equal?
It creates when the numbers of proton and electrons are not equals, it creates ions.
Yes, in particularly, how do you call it? How do you call a positively charged atom?
The positive charged atom called cations.
No, cation. 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 It's a cation, not cation. Cation. And
anion.
It's anion. It's not
anion.
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 Okay, anion and cation. Alright, very good. So, talking about structure of atoms, so science has already found ways to break open the atoms, and we manage to harness or harvest the energy of the atom through nuclear reactions. So that is something with physics, but have you learned about nuclear reaction before?
Reactions?
Nuclear reactions in physics.
I don't think so.
Okay. Alright, so let's talk about the atomic, molecular, and molar mass relationships. So what can you say about this relationship between molar mass, M, molecular mass, molar mass, atomic mass? Okay, so in an atom, most of the mass lies in the
nucleus.
So does it mean that the electrons' mass are insignificant? Is insignificant? Are they insignificant?
Yes.
I think it's better to say they are insignificant. True. It's better to say true, you know. Okay, true. They are insignificant. Because the mass of electrons are very small, like 1 out of 2,000 or 3,000 compared to the mass of a proton or a neutron. However, the charge, they carry charge. Now, so tell me, so if I have carbon, 12, 6, what does it mean? What are these numbers?
It means that the carbon consists of 6 Yeah, weight about the carbon has a mass weight about 12
12 what?
12,
What is the unit?
12 units.
12 units, 12 atomic mass units.
12 atomic mass units, and it contains 6 protons and 6 electrons.
So it should be 6 electrons as well. Right, okay, talking about that, okay, very good. Now, so is the number of protons and neutrons always the same in the nucleus?
No, no, it can be different.
Can you give examples?
The example would be, the atoms can have many isotopes. So
isotopes, since you talk about that, yes. We'll ask about that later.
The isotopes has a different number of neutrons, so which lead to a different, related, lead to the difference between difference of mass between these carbon atoms.
Between different carbon atoms, like for example, you have carbon 12-6, you have carbon 13-6, you have carbon 14-6. So those are isotopes. So what else are there about isotopes? What are the differences between isotopes? Why isotopes matter? Why do we need to know about isotopes?
Well, the isotopes, it has different numbers of neutrons.
Neutrons.
Neutrons. So it kind of have a difference, boiling point, or
that's wrong. That's not correct. Isotopes are basically the same element. However, they are just different in their number of neutrons. But however, they are still the same element. So it means their boiling point and melting point must be the same. Be careful. Cẩn thận nhé. Be careful.
Yep.
So carbon 12-6, carbon 13-6, carbon 14-6, they must have the same boiling point and melting point. Be careful. Because they are basically same. They are carbons. Because they are carbons. Alright. Be careful with that. Now, so since you talk about boiling point and melting point, let's move on to something else. I assume that you can do chemical equations and stoichiometry very well. Yeah. So you pass. Of course, you pass the written test. So of course you managed to do this one quite well. However, I think I'll ask you later about redox reaction. But that's for later, okay? Now, let's talk about quantum numbers, orbitals, and electron configurations. Electronic structure of the elements. Can you talk about these things, please? First, let's talk about orbitals. Orbitals first.
Okay. Orbitals in chemistry. Orbitals in chemistry called a wave functions that describe the characteristics of no more than 2 electrons in the vicinities of
the vicinities
in the atomic nucleus.
In the atomic nucleus. So, of course, they have something to do with orbit, isn't it?
Yeah, sure.
Right. So can you describe, can you give an example of orbitals? Just give example.
Example would be, S orbitals or P orbitals.
Yes, we have D and F as well, but that's too much. That would be too much, I guess. Okay, give an example. Let's talk about chlorine. Which group does chlorine belong to?
Chlorine belongs to group 7A.
Okay, group 7A. What does it mean, 7A?
It means it has a electron configurations of 7.
Nope. It has the outermost shell.
Outermost shells.
The outermost shell, phân lớp ngoài cùng. The outermost shell has 7 electrons. Electron configuration means like all the electrons, how they are built around the nucleus. But the outermost shell is something else. It's just like the outermost and the inner and the, there are many shells, but we're only talking about the furthest or the outermost shell. Electron configurations is everything, all the electrons around the nucleus. Cẩn thận nha, be careful. There's a lot of concepts that people keep, mixing up. You have to be very clear, because this is medical school. You cannot confuse between concepts, basic concept like that. Okay, that could be the difference between BMC, basic medical course, and landing a good spot in the first year, If you know your stuff, if you know your things clearly, correctly, and deep enough, you can get to first year. But if you keep confusing like basic concept like that, it's basic medical course BMC though. Now, let's talk more about electron configuration. Okay, chlorine. Which group? Okay, chlorine, it's 35.5 and 17, I guess. Yeah, 17. Can you write the electron configuration in the chat? Yes, in the chat. Can you write the electron configuration of chlorine?
Okay. Go.
1s2, 2s2, 2p6.
Oh, five.
No, it's 3s2, 3p5.
P5.
3p5. Okay, so what does it mean now? If it's 3s2, 3p5, what does it mean?
It means that the third, which is the outermost shells, has 7 electrons.
And it is subdivided. It is subdivided into s and p orbitals. Subdivided. Subdivided. So it is subdivided. So it is, or you can say it is further divided into s and p orbitals, for example. Or you can use the word subdivided to subdivide something as a verb. Now, right, so I don't think you can just draw everything out, like the arrows and everything, right?
Yeah.
Okay. Okay, let me open my iPad and we can work a bit by sharing the screen with you. But first, let me connect and pair my iPad with the laptop. Okay, so basically I was talking about the orbitals. Let me just erase this one. Yes. So when we talk about chlorine, so chlorine 35.5, 17. So it's 3s2, 3p5. So the electron configuration, I mean the cloud and things like, and then yeah, this is what I mean. Of course, p is like 3 square, isn't it?
Yeah.
So how do you fill in these squares? These squares represent the orbitals. How do you fill it in? Which rules do you use to fill it in?
We first fill the s orbital first.
Yes.
With 2 arrows.
Up and down, isn't it?
Up
2
and down,
arrows,
yes.
up and down.
And then we fill the next 3 boxes of the p orbitals.
Down, down, down?
Yep.
Is it down, 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 or up, 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 or something?
It's up, up.
That's according to Hund's rules. 1, 2, 3, and then?
And then we fill the rest of the electrons by down arrows.
Very good, young man. So, this is according to Hund's rules, another puzzle. Don't remember the name, but anyway. So what does it mean if the 3p, if there are like one lonely suborbitals like this in the 3p? What does it mean?
It means it tends to attract electrons to fill it to complete the
complete. To complete. So it means that in a scenario, chlorine atoms are likely to attract or to accept an electron, isn't it?
Yes.
And it becomes
minus chlorine.
No, chlorine.
Chlorine
is a chlorine anion minus here. Okay, but does it always happen that way?
Yes.
So this electron configuration also means that chlorine can be linked to other atoms in a substance with only one bonding, isn't it?
Yes.
So how do you explain? Okay, let me say. Okay, so basically, let's say sodium and chloride. So of course, chlorine has 7 electrons around it, isn't it?
Yep.
So the sodium can only give its only electron, isn't it? Right. So it means that you have a situation of NaCl like this. So it means that the chlorine form only one bonding, isn't it?
Sure.
Now, so how do you explain situation when you have something like this? Do you know how to draw the structure of this compound?
No, actually.
You don't?
Yep. And then
That's what you have to learn. I'll send you a few videos of mine showing you how to do that, okay? So this is a bit deeper. You have to understand that what you see here in the electron configuration are the basic state.
Yeah.
The basic state or the resting state. However, electrons can jump to the next empty orbitals if they are provided with an energy source, or we call it excitation, you know.
Yeah, sure.
Excitation, so they become something called excited state. Excited state, so basically an electrons can just jump to the next empty orbitals, you know? And so in that scenario, we can create a lot more half-filled orbitals. Sorry, my handwriting is not that great, because I'm not so used to writing on the screen. Okay, we have a lot of half-filled orbitals if the electron jump to the empty orbitals, like, you know, upper orbitals. And that can create the situation that we see down here, sodium, chlorine, and 4 oxygen. So if I write it, it should be like this. Have you seen something like this before? No?
No, I have.
Okay. So it creates a situation where a chlorine can can form like 7 bondings because the electron jumped to like empty orbitals, you know. Alright, that will be something that you need to learn more, okay? These are deeper things. Okay, now I need to eliminate this one. Delete. Okay, let me go back to the topic list a bit. Do you still see my screen?
Yep, I still see.
I mean the topic list.
No.
No, never. Okay, I need to reshare with this one. Okay. Now, so that is about orbitals, electron configuration you need to work on, okay? Now, let's talk about quantum number. Do you know what quantum number means? Yes?
I forgot.
Okay, quantum numbers. It's closely related to the electron configuration. It basically is the address of the last electrons that you draw into the electron configuration. So you need to watch that video as well. Okay. Because quantum numbers are actually quite difficult and it is in the topic list. They will ask it. Okay? Now, so I'll send you a few videos and then next time, hopefully, we can answer those hard topics. Now, can you describe the periodic table?
The periodic tables. The periodic tables is the most important chemistry reference there is, and it arranges all the elements in an informative way.
Sorry, in an.
I'm sorry.
In an. I can't hear that.
Informative.
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 Second syllable. Informative way.
Okay. And elements arrange
Informative.
left to right and top to bottoms in orders of increasing autonomic numbers, and with the increase of autonomic mass.
Okay. Right. Okay, so let's look at a periodic table. Alright, let's look at a simple periodic table. Need to close this one. Alright, so looking at this one, what can you say? So you said something about increasing and decreasing something. Can you say that again?
The increasing of autonomic from top to bottoms and from left to right, the increasing of autonomic mass.
Yes, it's true because the number keep increasing. So increasing atomic mass, they get bigger, heavier.
Yep.
Okay. How about atomic radius or radii? Plural form, radii. Singular form, radius.
The autonomic
radius, like how big an atom is, the radius.
Yeah. The trend of the radius from top to bottoms and from right to left, the radius tend to increasing. Tend to
increase. So you said like from top to bottom, the radius increases, and from the right to the left, it increases. But why? From the left to the right, why does the radius keep decreasing? Why? What's the reason behind that?
Because from the left to right, the numbers of protons keep increasing, and because that is it has a stronger force to stronger attraction force for the outer.
It has a stronger attraction force to the outer electron. Because, okay, it's better to say that because from the left to the right, the number of protons and electrons, you have to say both of them, okay? The number of protons and the number of electrons keep increasing. And that creates more and more and more attraction between proton and electrons. So what does it lead to?
It leads to the radius became smaller.
Yes, because plus and minus keep attracting each other more and more and more. So it basically squeezes the shells, it squeezes the electrons closer to the nucleus. Nó giống như nó squeeze, nó bóp nặng cái đống electron đó, nó kéo vào sau cái nucleus vậy đó. It squeezes the electron closer to the atoms, to the nucleus. Okay, so it creates a smaller radius or radii because of that. Alright, very good. Very good. Let's talk about electron negativity. What do you know about it? Electronegativity.
The trends of electron negativities is from the...
Okay, let's start first. What is electron negativity?
The electron negativities is it attracts the abilities of an atom attracts attracts lone pairs of electrons toward itself.
Toward itself.
Towards itself.
Okay, toward itself. Very good. So, can you give us a few examples? Just like few examples of electronegativity of some elements, you know?
For example, the chlorides.
Fluorine.
Chlorine.
It's fluorine.
Chlorine, which is a high electronegativity elements.
Okay, let's use the adjective form that it's highly electronegative. Adverb and adjective form. It's highly electronegative. So what is the value of fluorine? Electronegativity of fluorine. Fluorine. 4.0. It's 4.0.
4.0. Okay.
Which is the maximum possible in the whole periodic table. So what does it mean then?
What does it mean? It means that it's the maximum number, so it only decreases.
No, it doesn't mean that. That's not what I say. That's not what I have in my mind. 4.0 is the maximum electronegativity. So it means that fluorine has a very, very strong ability to attract electrons into its nucleus, isn't it?
Yep.
Into it. So it means when fluorine, when it forms chemical bonds in chemical reactions, those bonds tend to be extremely ionic, very polar. Rất phân cực. Very polar, extremely ionic, because it just squeezes electron into it, isn't it?
Yeah.
And the bonds become extremely, unequal. It's unequal sharing. Unequal sharing, sự chia sẻ không đồng đều. Unequal sharing between like atoms. Like for example, NaF. Sodium is like 0.8. Fluorine is like 4.0, so of course, fluorine just like squeezes electron into it so much. And it results in this particular bonds being like very ionic. It's not even polar covalent, it's ionic. Nó không phải là polar covalent nữa, nó không phải là cái liên kết hóa trị mà phân cực nữa. Mà nó là cái gì? Nó là liên kết ion luôn. It's ionic. Alright, so very ionic. Okay. Can you explain the trends of electronegativity in the periodic table and explain the reason behind that? Explain it.
From left to right, the trends, the electronegativity increase.
Just say from left to right, electronegativity increases. Why? What is the reason? It doesn't happen that easily. Okay, look at this one. You will see what I mean. Okay, so there's a trend of electronegativity, but it doesn't always happen the way you want. I'm showing you something. It doesn't always happen the way that you think it is. Let's look at this picture for a while. You see it?
Yep, I can see it.
So, Let's look at this one. Potassium, calcium, strontium, titanium, vladimium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, germanium, arsenium. Okay, of course, it keeps increasing somehow. However, there are some exceptions, I think. As I remember, there's some exceptions. Like you can see here, it keeps dropping sometimes. But I think going into shielding effect and everything else is a bit too A-level. Have you learned A-level before?
I hope so.
You haven't, right?
Yeah.
You can say, no, I haven't. Okay, so this is what I was talking about. Periodic trends in electronegativity. So you can see here, group 1, here is hydrogen. Group 2, lithium all the way to fluorine. It's linear, isn't it? Theo đường thẳng. It's linear like this. Group 3, sodium, aluminum, chlorine. It's quite linear as well, but you can see it's not exactly. But group 4, you can see it's going up and then drop down, going up again and drop down and going up. Group 5, you can see it's like starting from here, going up and then drop down, going up again and drop down and then going up again. And then group 6, same thing happens. So what is the reason why you experience something like this? Why does it drop down? Why is it not going up like, you know, linear like this? You know why?
I think because of the orbitals and the electrons, filling the because electrons jumping and filling the orbitals. For example, Nicole, I believe.
Nickel, yeah.
Nicole. The electrons from the 4s tend to jump to fill the empty orbitals from the 3D shell.
Yes.
Which
electronegativity also explain like how easy it is to accept an electrons. How easy it is to accept or attract electrons from anywhere. I don't care. Just attract electrons. So of course, so basically group 7, when you have 7 electrons already, you really want to get one more to achieve the full octet, right?
Yep.
So that's why very high electronegativity at group 7. Okay, let me explain like this. Alright, I'll stop the share here and I'll share with the iPhone iPad. And you can see. Okay, I'll mirror. Yes. And alright. Okay. Now. Okay, so let's start from 7. So this is group 7. So basically it's very easy to accept one more electrons into here, isn't it?
Yeah.
Very easy. So basically, they really wanted to achieve the full octet, so that's why group 7, it's very high. Now, let's look at the situation a bit differently. Okay, group 6. Accepting 2 electrons, it's a bit more difficult compared to accepting only 1 electron, isn't it?
Yeah.
Okay, how about the situation? You have to accept 3 more. How about the situation? Sometimes it's not that easy to understand this trend, but you can explain it with like a shielding effect. Hiệu ứng shielding effect. Like electrons next to each other, they tend to shield each other. Những cái electron cạnh cạnh nhau có xu hướng là nó sẽ đỡ đầu cho nhau, shield cho nhau. It's like shielding effect, you know. You can use shielding effect to explain this trend in electronegativity. Okay, anyway, I guess this one is also in my video too. You can watch that.
Yep, sure.
Now, so let me delete this one. Stop share here and then share again. This one. Alright, we're back. Alright, be careful with electronegativity, okay? Okay, what do you know about noble gases? Tell me, noble gas.
Noble gases are elements from the groups 8A.
8A.
They tend to be in gaseous state, and their orbitals are being fully filled.
So they already fulfilled. What does it mean? When the electron configuration, everything is fulfilled.
It means it doesn't attract any pairs of electrons.
It means these noble gases, these elements, tend to be inert. Inert means they do not want to react with anything else. Inert. They're very inert. So, what do we use noble gases for in practice, in reality, in the industries? Based on the properties that I just said before, it doesn't react with anything else. So how do we use noble gases in the industry, in our daily life? Yes?
I can't think of anything.
Think about neon light.
Neon light.
Yes. Neon light. Inside, you can find these are of course inside the neon, which is a noble gas. So why do we use noble gas? Because basically it doesn't react with anything else. So inside these lights, electrons can just fly from this end to another end easily without reacting, you know. So in other words, noble gases helps this light to function easier. We also have other uses for noble gases. Okay, but maybe it's better if you search for it on your own. Now, let's talk about types of chemical bonds now. Yes? Can you talk about types of chemical bonds?
Yes, many types of chemical bonds, which includes covalent bonds, ionic bonds, metallic bonds, and hydrogen bonds.
In covalent bonds, we have non-polar covalent and polar covalent bonds, okay? It's like we have polar and non-polar covalent bonds. Oh, sorry, bonds like this. Có phân cực, chúng ta có liên kết hóa trị phân cực polar và không phân cực non-polar. Okay, what are the differences? What are the differences between them?
The difference between them is that the covalent bonds, polar covalent bonds, are born between two very different electronegativities
between two atoms that have
a difference of electronegativities.
How much difference? It's from 0.5 to 1.8. Like for example, look at the CCl bond, carbon and chlorine bonds. So the electronegativity for carbon it's
I don't know the number.
I would suggest you should know nitrogen, hydrogen, carbon, of course CHON and then Cl, okay? Suggest you know like, and then of course fluorine is like 6. So 6 elements. You should know these numbers because those are the most common. So look at this one, chlorine and carbon bonds, 2.5 and 3.5. The difference is 1.0. So how would you classify this bond? What type of bond is that?
It's a polar, I think, non-polar.
This is polar covalent.
Polar.
Because 0 difference is 0 to 0.4, that is considered as non-polar, không phân cực. Because the sharing is quite equal, isn't it?
Yeah.
However, from 0.5 to 1.8, that is polar covalent. More than 1.8, it's... More than 1.8, what is that called?
Ionic.
Ionic bond, very good. Alright, so sodium chloride, for example, how would you rate that? Sodium and chloride is like 0.8 and 3.5.
It's ionic.
Of course it's ionic. Of course it's ionic, yeah. Alright, good. How about, okay, can you describe hydrogen bonds? What are hydrogen bonds? What does it form? How does it form? What is it?
Hydrogen bonds is a type of intermolecular force. It's formed between hydrogen's atoms with a highly electronegative.
Highly electronegative.
Electronegative atoms such as oxygens, fluorine, nitrons.
3 cases.
Yeah.
Nitrogen, fluorine, and oxygen.
And nitrogen.
N, F, and O, isn't it?
Yep, F and O.
So basically, it's the bond that forms between hydrogen, not any hydrogen, isn't it?
Yep.
Đâu phải cái nào hydrogen là cũng được hả? Isn't it?
Yeah.
You have to say no. Câu hỏi yes no phải trả lời một chữ no mới đúng nha. This yes no question you have to answer with a no, because not any hydrogen will do. Because if you look at this one, let me stop share and I'll share with my iPhone iPad again. You will see. I'll click on the screen mirroring. It takes a few seconds because the internet in Vietnam is not that great. Anyway. Okay, let's look at this one. CH4. And then, of course, I have H2O here. Oxygen has two lone pair, isn't it? Yes. So the question is, can hydrogen bonds happen between this one and this hydrogen? Is it possible?
Yeah. Yes. Possible.
If it's possible, it means methane, CH4, it's soluble in water, isn't it?
Yep.
Are you sure? Are you sure? Are you absolutely sure about that?
Well, it can form hydrogen bonds. Yeah, sure.
No, not true. Cyril.
No.
Basically, hydrogen. Okay, the situation, it's all based on electron negativity. So look at this one. Hydrogen is 2.2. 2.2. Oxygen is like 3.5. But then look at this one. This hydrogen is like 2.2. Carbon is 2.5, isn't it? This bond between C and H, it's a non-polar covalent, isn't it?
Yeah.
This one, it's a non-polar covalent. So what does it mean? This hydrogen, it's not positively charged like this. It's not positively charged. So it means that this hydrogen is not strong enough to form a hydrogen bonds with the water. Không đủ nha, không được. However, look at another case. I'm going to draw an ammonia, for example. I can draw it any way I want, of course, as long as these bonds are apart from each other. Of course, ammonia has a lone pair, isn't it? Ammonia?
Yeah, it has a lone pair.
The question is, can hydrogen bond happen between this one and this hydrogen?
It can happen because
why?
Of the numbers of the nitrogens is very high.
What's the
between
number of hydrogen? What's the number of nitrogens then? The
and
number is
nitrogen.
3.0.
Yeah, it's form a polar and covalent bonds between the hydrogen, so it can form hydrogen bonds.
But I'm not convinced. Why is the case of methane doesn't form hydrogen bonds, but the case of ammonia, it can form hydrogen bonds with water? Why? That's the question I'm having. See? You don't know exactly. You don't know in details. Okay, so let's look at this one. Look at the water molecules. You can see that the oxygen is 3.5 and the nitrogen is 2.2, isn't it? Very, very polar. So it means it creates a partially positive charge here and a partially negative charge here at the oxygen, isn't it?
Yes.
Partially positive and partially negative. Because of this one, the nitrogen, the hydrogen of the water is good enough to form hydrogen bondings with the electrons of the nitrogens of the ammonia. You know, it's because it also depends on like two molecules, you know, not just one molecule, you know, nó tùy thuộc cả hai cái nguyên cái phân tử luôn chứ.
Yeah.
So, hydrogen bonds can form between the lone pairs of nitrogen, fluorine, and oxygen, and the hydrogen of another molecule that is connected to a highly electronegative atom. That is the definition, the full definition. You know? Nó phải là nó kết nối với một cái hydrogen của phân tử khác, mà cái hydrogen đó nó phải liên kết với một cái atoms mà có độ âm điện cao nữa cơ. You know?
Yep.
Alright. In the case of methane, carbon is not strong enough, isn't it? It's not electronegative enough, you know, so that's why no hydrogen bonds. But in the case of ammonia and water, there is hydrogen bonds. There are hydrogen bonds, yeah. Alright, good. This is hard, isn't it?
Quite hard. Chemistry.
Of course.
For me.
This is deep, this is quite deep. You need to be careful. Okay. Covalent bond, Lewis structure. Okay, how to draw structure. Do you know how to draw structure? Lewis structure? Like dot structure, mấy cái cấu trúc với hình có dấu chấm.
I can draw.
Good. How about molecular shapes? You know the shapes of some molecules and you know how to explain them?
I think I can.
You need to go very deep. Okay, we don't have enough time. It's 9:20 already, so these things I think you can watch my channel, my videos, and I'll explain it easier. Intermolecular forces. What type of inter in between the two molecules? We have intra, which means inside, and inter means between. So what type of intermolecular forces do you know?
The intermolecular force consists of electrostasis, the London
dispersion force,
dipole attractions, hydrogen bonds. That's all I know.
How about van der Waals?
I
think it's van der Waals. I don't know how to write that name. Van der Waals. I think Van der Waals and London dispersion force are basically the same thing.
Yeah. Yes. Same.
Alright, so how about the strength of these forces and how they are formed?
The van der Waals is the weakest force. The force is the force that held the molecules together in the liquid, solid, or solutions. They are generated as the molecules collide.
The bigger the molecule, the more London dispersion force.
Yep.
Because it's based on the mass of the molecules. It's like, you know, it's like Newton's attraction force, you know.
Yeah.
Newton's attraction force is used for massive things like planets, stars. But in the molecular world, you have London dispersion force. They are essentially the same thing. Nó y chang nhau á thực. Okay. So the bigger the molecule is, the more the stronger the London dispersion force. Okay, anything else?
Because of that, there's some in addition to the London force, we have molecules. We have molecules which are polar. So we say that the molecules has a permanent dipole.
Permanent dipole. Okay, permanent dipole. So because of the charge, partial charge on these molecules, they attract each other, isn't it?
Yep.
Okay. How do you explain all the forces? Okay, we did explain hydrogen force before. Okay, good. Alright, let's go to the gas law. What do you know about the gas laws?
Gas law?
Yep.
Gas law. No, I seem to forget.
Sorry?
I seem to forget.
Okay, gas laws. We have Charles laws, Boyle's laws, and Avogadro laws. But we also have the ideal gas law as well. Ideal gas law. Quy luật về khí lý tưởng. Ideal gas law. Okay. Tell me.
Tell you.
What is that? Well, yeah. Can you tell about? What could you say about ideal gas laws?
Ideal gas law. The ideal gas law states that it's written in a formula, which is where the pressure times the volume equal to the mole times R constant times the temperature.
Times temperature. Can you say that again? Can you say that formula again? Pressure times
volume equal to moles, number of moles times R constant times temperature.
Very good. Do you know the units of those things?
Yeah, not quite. I know the temperature is Kelvin.
The temperature must be in Kelvin because we are talking about scientific experiments, and in science, Kelvin is used. Okay, how about pressure and volume and the R value?
Volume is millimeters.
Millimeter mercury? Millimeter mercury?
No. Milliliters.
Wrong.
Liters?
Basically in ideal gas laws, the units depends on the R value. So it depends on what R value they give you. Depends on the unit of the R values. Nó tùy vào cái đơn vị của cái R mà người ta cho mình đó. So depending on the R value, look at that units, you can figure out, okay, what unit do I need to use for pressure and volume? If the R value has millimeter mercury, then you must use millimeter mercury for pressure. Or ATM, you need to use ATM for pressure, for example. Nó tùy nha, không có fix nha.
Okay.
So it's not fixed, you have to understand that. Alright, you know a lot more today than you did before the class.
Thank you.
So you're welcome. Stoichiometric relationship of gases. Kinetic molecular theory of gases. Do you know the phase changes? Cái đầu thầy của điểm 3. You know, like the graph that has a triple point.
Yep.
Điểm 3, the triple point. Can you explain that? The phase changes in, say, a random something. Let's look at something like this. Yes, I believe this picture is good enough. Alright, can you explain this one? Okay, so we have a temperature versus pressure graph. Yes, what can you say?
The 2 points where the substance can be liquefied, vaporized, or being solidified.
Wow, those such formal words. You can just say become solid, but then you say solidified. Formal trinh trọng dữ ta. Alright, okay, so can you explain triple point again? What happened in a triple point? What happens at triple point? At triple point, all 3 states coexist. Nó cùng tồn tại cùng lúc 3 trạng thái luôn. All 3 states coexist. All 3 states of matter coexist. 3 trạng thái vật chất nó cùng tồn tại ở cái điểm đó luôn. Like it can be both solids, it can be solid, liquid, and gaseous. At that point, triple point. Of course, every substance has their own triple point. It has their own like graph. All right. So, can you explain what is critical point then? When the temperature and pressure is very high, then the substance becomes something called supercritical fluid. Cái trạng thái nó giống như it's like very liquidish, so that's why we call it fluid, you know.
Yeah.
Never mind. I think that's a bit too that's too deep.
Yeah,
All
I
right.
never that's before.
All right. But then be prepared for these questions. It can be that hard. All right. So today just like chemistry. Do you know how to do Hess laws? Like calculating like the energy delta H,
I can calculate that.
entropy, something like that.
Yep, I can calculate that.
I trust you. All right, because calculation for Vietnamese students, calculation is easy for them. All right. Balancing redox reaction. Can you do that?
Sure. I've studied before.
Are you sure? Okay, I believe that calculation you can do that. All right, so in organic chemistry, not much to ask about these things, I have to say. You just have to read about their applications, okay? Đọc nhiều về cái ứng dụng của nó là được. Alright, organic chemistry, chemical reactions. Alright. Okay, let me ask you a bit about biology then.
Okay.
I'll ask you topic number 16. The basic defense system against infection. The humoral and cellular immune response in humans. What can you say?
The defense system against infections of human contain two types of defense. The specific defense and non-specific defense.
Specific. Những dòng hai nha. Specific. Second syllable. Specific.
Non-specific defense.
None. Not non. None. Non-specific.
Non-specific.
Non-specific. Non-specific.
Non-specific defense consists of the barriers, skin barriers, these external glands that help to destroy pathogens.
What external gland are you talking about?
For example, the saliva glands, sweat
Saliva. Yeah, saliva is actually a good defense.
Or tears gland.
Tears, of course, producing tears. Tears protect the eye, yeah?
That's the first line defense. The second line of defense, also non-specific, which consists of white blood cells, such as basophils, phagocytes,
basophil, eosinophil, monophil, macrophage,
and also natural killer cells.
Natural killer cells, what are they for?
They are for to destroy affected cells.
They hunt down affected cells and cancer cells. We know more about natural killer cells now thanks to research. Natural killer cells help to protect the body against cancerous cells as well. Cancer cells. Nó chống ung thư, chống lại các tế bào ung thư. Okay, so what else? Non-specific.
Also, there are reactions.
Oh, you forgot to mention neutrophils as well. Trung tính và cực tính. Neutrophils.
And also reactions for inflammations.
Inflammation, yes.
Inflammations. And moving on to the specific cells, with the specific cells are the and with the help of the lymphocyte, which includes lymphocyte B and lymphocyte T, this cell help to fight off, act as a third line of defense against the pathogens.
Third line of defense. That's
Line.
interesting to keep it, to make it that way, to say it like that. Okay, so you talk about B and T lymphocyte, isn't it? They are part of the specific immune response, isn't it?
Yep.
Aren't they? Yep.
Yes.
Okay, so okay, please continue. How long does it take for T cell and B cell to be activated and to do something useful to defend the body?
It would take quite some time because it has to follow by steps. First, the macrophage and all the others consume the pathogens and uses protein to represent to produce the receptors, MH2 receptor.
You don't have to be that specific,
Okay.
If that's too specific, you will learn that in third year, or if you study medicine, right? You will study medicine, right?
Yep.
Okay,
Yep.
so second semester of second year, you will learn immunology. All right, MH2 class, major histocompatibility complex, MHC class 2, isn't it?
Yep.
Class 2 is for CD4 plus, which is what's it called? CD4 plus. One is like cytotoxic T cells, like CD8 plus. CD4 plus is like T helper cells.
T helper cells.
Yes.
Represents for the T helper cells to attach and recognize when the T helper cells is attached to the antigens represents cells.
Antigen presenting cells.
Antigen presenting cells. Began to release signals to proliferate.
Yes. And then it takes a few days for the T helper cells to teach the B cells. So the B cell will choose a clone that is suitable to produce like antibodies, isn't it?
Yep. It's undergo. It undergo clonal selection.
Very good. Clonal selection, and they choose a right clone, and after a few days, your B cells will start to pump like trillions of antibodies in your bloodstream. And those antibodies, what do they do?
The antibodies, it attach, it connect, it recognize and attach to the pathogens in order to deactivate the pathogens receptors for being
it neutralizes. Okay, to neutralize something, it neutralizes them, or it can also mark them for the other white blood cells to come and destroy it, isn't it? Giống như chỉ điểm vậy. It's like mark them for destruction. Đánh dấu để mà bị tiêu diệt. Just like mark them for destruction. Alright, let me ask you about basic structure and function of skeletal muscle cells. Locomotions in human. Alright, can you describe it?
The skeletal muscles, the skeletal muscles consist of many layers, and the basic unit of the muscles, skeletal muscles, muscle fibers, and these muscle fibers, consist of many types of structures which consist of the myosins and actins.
Actin and myosin are proteins that slide past each other when the muscle contracts, isn't it?
Yep.
Now, so what is the function of the sarcoplasmic reticulum?
Of the
Sarcoplasmic reticulum.
The muscles get signal from the motor neurons and it received the actions potentials. It's open to get for the sodium ions to flush in, create action potentials inside the muscle cells.
Yes, but what I asked is what's the function of sarcoplasmic reticulum?
Because of that, the sarcoplasmic reticulum releases
calcium ions. And what's the function of calcium ions in this case?
The calcium ions functions that it helps the myosin head to connect to the connecting side of actins by the calcium ions interact with the triple myosin in order to show the contact sites, connecting sites for the actin to be connected. For the connected actin. Okay.
All right. So, what's the function of ATP in muscle contraction then?
The ATP helps to the ATP when high hydrolyzed is help the ATP help the myosin head connect to the actins, cross which side and help the and also when the myosins push the actin closer together,
Okay, the ATP functions to break that linkage.
Yep.
So in the case of dead people, of course, there's no more ATP. So dead people, their muscle is extremely rigid. So it's this is like a situation called Rigor Mortis, or stiffening of the muscles when someone died. Tình trạng mà gọi là gọi là căng cứng lúc chết. Rigor mortis means like the muscle become extremely rigid when a person died because no more ATP to break the linkage between actin and myosin. So basically, the muscle cannot contract; it just basically become very stiff. You know? Trong vòng 72 giờ sau lúc chết, about 72 hours after the person died, rigor mortis happens. Now, so alright, we should move on to 14, homeostasis. Hormones and the human endocrine system is a huge topic. What can you say about that topic now?
The hormones. The hormones.
Homeostasis.
The homeostasis. Say about. Consists of organs that secretes hormones to balancing the internals of the bodies, and balancing out the internal of the bodies, and it consists of many many organs that produce hormones.
Yes, but what exactly does the term homeo and stasis?
Homeostasis.
Homeo is the environment inside the body. Stasis means to keep it the same, to maintain it, to keep it the same. Giữ vững môi trường bên trong cơ thể. Homeostasis means to keep the environment inside the body the same. So no big changes that can disrupt the normal functions. Alright, let's talk about human endocrine system now in deep details.
It includes many endocrines. Endocrine organs that creates hormones such as hypothalamus.
Hypothalamus, okay, all the way here. Hypothalamus, right in the middle of your head.
Yep, which is the inside of producing hormones.
RH, releasing hormones. RH.
Can you repeat?
Basically, hypothalamus is the site that produces releasing hormones. RH.
Releasing hormones.
It controls the secretion of the gland below it, which is the pituitary gland.
Pituitary glands.
Nó điều khiển cái tuyến đằng dưới nó là cái tuyến yên á. Yep. Nó sản xuất ra cái RH releasing hormone để mà điều khiển cái tuyến bên dưới. So it produces releasing hormones just to control the pituitary glands below it. Please continue.
There are also pineal glands, other pineals, the kidneys, the thyroid glands, the
thyroid gland. The kidney is actually part of the hormones, human endocrine system, because the kidney produces renin and other kind of hormones to regulate the blood pressure.
Yep.
However, the kidney is not exactly, how can I say, the main topics of human endocrine system. You will learn it later, but not the kidney, I think.
The adrenal glands.
Adrenal gland. Tuyến thượng thận, adrenal glands, is the glands above the renal, above the kidney. Yes, I'm listening. You have 10 more minutes.
Em quên mất tiếng Tuyển.
Okay, what are you going to say now?
Tiếng Anh.
Pancreas.
Pancreas.
Pancreas. Tiếng Tụy. pancreas, well, it's below the stomach. Below the stomach. Yeah, what does it do?
It releases two types of hormones.
Two main types, because there are other types of hormone as well. Pancreas produces
two main types.
Two main types. So beside from insulin and glucagon, it also produces a lot of digestive enzyme, you know. But if you talk about hormone, there are two main types. True. Please continue.
And also gonad hormones, which the reproductive system as well.
Yes, that is the gonads, or the testes and the ovaries. Testes for men and ovaries for women. Go on, please.
And that's all.
Okay, now please go deep into the function.
Okay. The hypothalamus is releasing hormones, which
hormones, not hormones. 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 The hormones.
Hormones. And into the pituitaries, which include anterior pituitary glands and posterior pituitary glands. Anterior produce 6 other types of hormones, and the posterior produce 2 types of hormones. Which includes oxytocins and ADH, while the anteriors includes gonadotropes, prolactin, adrenocorticotropes,
adrenocorticotrope, ACTH, I think.
Thyrotropes,
TSH,
and gonadotropes,
GNSH.
Yep. And this
gonadotropin stimulating hormones, GNSH. Yeah.
GNSH.
What else? Okay. Anything else?
Somatin.
How about FSH? Follicle stimulating hormone. FSH.
Yeah.
All right.
LH.
My question is, what does the GNSH do in men and women? What does gonadotropin stimulating hormones do for men and women?
The gonadostimulating hormones affect the testes to release testosterone, while in women it makes the ovaries.
It acts on the ovary. It acts on the ovary. Nó đánh vào ovary trước đã. It acts on the ovary to
release estrogens and progesterone.
Wait, is it called progesterone? Let me check. Estrogen and progesterone, yeah. So tell me, what is the function of estrogen and progesterone in women?
The functions is to help to maintaining the growing the reproductive systems and
growing of the ovary, growing of the reproductive system of women, and
help to maintain the corpus lectums.
Corpus mean body.
Luteum, cái thể vàng.
Corpus luteum.
Corpus luteum.
Corpus luteum. Thể vàng. The yellow thing. Corpus luteum inside of the ovary. Okay, let's just say that they helps the ovary and the uterus to develop more. It also estrogen helps the breasts of women and helps women to develop a higher voice. Cái giọng nó cao hơn, a higher voice.
Okay.
And the secondary sexual characteristics, những tính chất phẩm chất về sinh dục thứ cấp. Secondary sexual characteristics. Okay, just make them more attractive, of course. Now, how about for men? Well, okay, wait, I forgot. Progesterone, what does it do? Progesterone?
It helps to I don't know specifically.
Okay, progesterone are basically called the pregnancy hormone. Because it helps the pregnancy. It basically keeps the woman pregnant until the moment she gives birth to the baby. So what does it do? It keeps the uterus. It keeps the uterus intact. Nó giữ cho cái uterus nó ở nguyên, nó đừng có mà bị đừng có chảy máu, đừng có gì hết. Like it keeps the uterus like keep it there, like protect it. So, and basically it keeps the walls of the uterus intact. Nó giữ nguyên đó. And then it prevents a menstruation during pregnancy too. Nó tránh cái sự mà nó chảy máu mà tới tháng á. It basically prevents menstruation during pregnancy. Just, you know, menstruation basically destroy the uterus walls, you know, right?
Yep.
Nó tiêu diệt nó hủy cái thành của cái tử cung khi mà phụ nữ tới tháng mình bị chảy máu. Of course, basically, menstruation destroys the walls of uterus when the woman at her, you know, menstrual cycle. So it also basically can cause abortion too. Có thể gây ra sự sảy thai. So basically, you need progesterone to keep the pregnancy going. Anyway, that's a bit too deep already. I think it's time. You have any question for today's lesson, no? There are still a lot more you need to learn. Because if you talk just basically general things, I'm sure there's a lot of things I can dig deeper and deeper. Any question? I'll ask you more next time about these other topics.
Questions.
Sorry? You don't have any question?
Yeah.
No, you have to say no. Phải trả lời no.
No.
You have to say no. Okay. Alright, I'll see you then. Next week, Friday, okay? Same time. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh đó, để mà các bạn sẽ được thông báo về những video mới nha.
Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình, nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.